All right. Yesterday, what did we learn?
You get rational numbers from adding, dividing, multiplying, subtracting.
Yep. What process did we learn yesterday? We learned how to do...
Identify and classify rational.
We learned how to turn fractions into decimals, right? By using long division. So today we are going to turn fractions. We're going to turn mixed fractions into improper fractions. We're going to turn decimals into fractions. Okay? So what happens when you add, subtract, multiply, and divide rational numbers? What do you get? A rational number. Very good. So I talked about what we're going to learn today. What is a rational number? Start there again. What's a rational number? What makes a number rational? If you can turn it into a fraction. Yep, you got it. Okay, we've seen this before. What is this system called?
Yes.
First thing we learned this year. What's this system called? The real number system. Yep. You ask yourself, is it rational or is it irrational, right? And then if it's rational, you start working your way through the diagram, right? We're going to see that again today, okay? So here you have seen this before, writing each rational number as a fraction. Let's go through it. We have a whole number with a fraction. We want to turn it into one fraction. So listen up. We start at the bottom, start on the denominator with 6. Anybody know what our next step is? Multiply by 6. What's that? 36. And then we add 1. 36 plus 1? 37. So that is our new numerator. Oh, that is our new numerator. And then our denominator stays the same as what it was up here. Okay, so you start at your denominator, multiply, add, and then you rewrite. Yeah? That is writing it as a fraction. Yes, ma'am.
You can use TX.
You can use what?
TX.
What's that?
So, it's basically this.
What if we have a whole number? How can we write a whole number as a fraction without changing its value? How can we write a whole number as a fraction without changing its value? Put it over 1, right? Negative 23 over 1. Do we agree that this is a fraction? Does it change its value?
No.
No, because negative 23 over 1 equals
23.
negative 23, right? So if you have a whole number, all you got to do to write it as a fraction is put it over 1. So go ahead and try these two on your own. Try A and B on your own. Write them as fractions. All right, A. Where do we start when we do these?
Bottom.
So start at the bottom. Start on 8. What's my next step? Multiply by what?
4.
Yep. 8 times 4? 32. What's my next step?
Add the negative.
Add plus 3. 32 plus 3?
35.
35. So we have 35. What's my bottom number? 8. Denominator stays the same. What about that negative?
Negative.
Put it out in front. Yep. Just put it out in front. Good. What's a way you can check yourself on those to make sure you did it right?
Divide.
You can do it. You can do divide like we did. How many times does 8 go into 35?
4 times.
4. How many's left over?
3.
3. So you did it right. All right, what about B? How do we turn a whole number into a fraction?
10 over 1. Put it over 1.
10 over 1. Value doesn't change or anything. Nice job. Any questions over those? All right, now we're going to be writing decimals as fractions. Who's seen this before? This little table with tens, thousands, hundreds. You've seen it before. So we have a decimal here. You go one spot over. That's tenths, hundreds, thousands, and so on. A way that I explained it to my first period class. You have 0.64 here. How many numbers are behind the decimal point? 2. How many zeros are in our denominator? 2. So if you have 2 place values, you're going to have 2 zeros. So you need to have 100. What if I had 3? What would my denominator be? 1,000, because I'd have 3 zeros. What if it was just 1?
1 billion.
What if it was just 1 place value?
1.
10. 1, 0. We would have 10. Okay? Here we have 3, so they have 3 zeros, which is 1,000. Okay, if you want to think about it that way. All right? Go on to this one, 0.26. Go ahead and try this one and the next one on your own. Write them as fractions. 0.26, 0.26. Yep, how do you know it's over 100?
Because it's in the 6 is in the hundreds place.
Yep, so you need
Because
100 on the bottom.
Then to put the 0 on the other side, it would be 260 hundredths.
Mm-hmm. Yep, so you need 26 over 100. This next one, 2.875. What's that 2?
Whole number.
2 is a whole number, so just write it out in front. 875, what do I need on the bottom?
1,000.
1,000. There's 3 numbers, so I need 3 place values, 3 zeros. Okay? Look at those two. Are those in simplest form?
No. Yeah.
Look at the first one. Are those in simplest form?
No.
What does simplest form mean?
Like simplify
The
down.
lowest it can go.
The lowest it can go. So what's a number? What's a number that can go into 26 and 100? 2. So we're going to divide each term by 2. What's 26 divided by 2?
13.
What's 100 divided by 2? 50. So 13/50ths is the simplest form. Make sure you have it written down. 13/50ths. I want you to simplify when you can. Okay? What about that bottom one? The 2 stays the same.
5.
25. How many times does 25 go into 875?
Too many.
200. 400. 300.
35. How many times does 25 go into 1,000?
100.
40. Is that in simplest form?
Yes. Why does that sound so much closer than like actually?
What? It's not, right?
Oh,
What else can it be?
5.
5 can go into both of those. What's 35 divided by 5? 7. What's 40 divided by 5? 8. Now is it in simplest form? Yes. So then you're done.
The more that you like go smaller or something, like the more you simplify, it just gets closer to over.
Yep, it does. Good. Okay, questions on those before I move on? Any questions? Oh, sorry. This is where it's going to get a little iffy. Okay? Keep an open mind. We're not going to do it a lot, but you need to learn it. Okay? Keep an open mind. Everyone needs to be locked in right now. So, we have 0.6. What's that bar on top mean? Means repeating. 0.66666 over and over and over again repeating. Okay? So, they have n equal to that repeating number. Okay? How many numbers are repeating?
4. 2.
What's the digit that's repeating?
6.
6. That's the only one repeating, right?
Yes.
So we just have 6 that's repeating. So it's 1. We have 1 value that's repeating. So we multiply each side by 10. So we have 1 value that's repeating. So we need to multiply both sides by 10, which they did here. Multiply by 10. That n means nothing right now. It's just a placeholder. Okay? When they multiply by 10, this side just turns into 10n. Over here, when you multiply a decimal by 10, what happens to that decimal? It moves 1 value to the right. So that's how we get 6 and then we still have the repeating. We want to get rid of the repeating part. So we need to subtract 1. 1n on both sides. Subtract 1. If you subtract 1, that repeating part is going to go away. Okay? Repeating part goes away, so now you're just left here. And then it's an algebra problem. What's our last step to get n by itself? Divide by 9, right? Here, we have 0.39. How many digits are repeating?
2.
We have 2, right? 39 is repeating. So, how many zeros do we need? If 2 are repeating, how many zeros do we need? We need 2. So we have n equals 0.393939. Everyone write that out. We're going to get there. Everyone write it out. We said we need 2 zeros. So we need to multiply by what? What has 2 zeros? We need to multiply by 100 on both sides. Multiply by 100 on both sides. So on this side you have 100n. Everyone needs to be writing this down. What am I going to have left on the right side? What's that going to turn into? If I multiply by 100, 2 place values, take that decimal, move it 2 place values over to the right. Right, it turns into 39.3939. We still have that repeating part, right? How do I get rid of the repeating part? Subtract by 1n on this side. When you subtract by 1 on this side, what's 100 minus 1? 99n. What happens when we subtract on the left side? What happens to the right side? What disappears? The repeating number. So what am I left with? 39. Just 39. Repeating numbers are gone. Okay. What's my last step to get n by itself?
Subtract 90.
Divide by 99. So our final fraction is 39 over 99. With these, you do not need to reduce these. Okay, I just want you to get to this point. Do not worry about reducing once you get to here. Okay? Questions? Okay. Here, now we are going back to the real number system. What is the first thing you ask yourself when describing a number? Rational or irrational? If it's irrational, can it be anything else? No. If it's rational, what's your next question? Okay, what's your next step underneath? One more before that. Integer, and then whole number, and then natural number. Okay, so A, is that rational or irrational? Why is it rational? Because it's a fraction. Can it be anything else? Is it an integer? No, because it's not a whole number. Okay? What about B, rational or irrational? What? Why irrational? It's repeating, it doesn't terminate, and it doesn't have a pattern. So remember, repeating decimals can be rational, but this one doesn't have a pattern, so it's irrational. Okay? What about C? Rational. Is it anything else? Yep. It is everything, right? Rational, integer, whole number, natural number. All of the above. Okay? Go ahead and try these last 3 on your own. All right, on A, rational or irrational? Rational. Is it anything else?
No.
Is it anything else? No. What about B? Irrational. Can it be anything else if it's irrational?
No.
No. What about C?
It's all of the above.
Rational. What's next? Integer. What's next?
Variable.
Whole number. What's next? All numbers are what?
Real numbers.
Real numbers. Nice job.